We are connecting fiber link from the core to each building. Hey tech enthusiasts, welcome back to Fast Cabling. So today we're helping a client link 4 buildings into one IP camera system. And each building needs 8 cameras. And the control room sits 150 meters to 300 meters away from them. We'll weigh the options, explain them, and then wire the whole thing live on our demonstration board, so you can copy it step by step. First, what are our backbone options across this distance? We could try copper, we could play with wireless bridges, or we can go fiber. So we know copper tops out at 100 meters and hates electrical noise between buildings. Wireless could work, but we have 4 buildings, so it introduces spectrum planning, potential interference, and added maintenance. So fiber wins here because it goes long distance at full bandwidth. It is immune to electromagnetic interference and inherently isolates grounds between buildings for better surge robustness. So it's perfect for our 150 to 300 meters per one and beyond. So now we are in front of the demonstration board, and behind me is our setup for today. And this is our core, our 8+8 port fiber Ethernet switch with 1G uplink. It's a managed fiber switch designed to push high-speed links over long distances and let us manage the network centrally. Think gigabit switching, gigabit uplink, and remote management, so we can tweak VLANs or monitor links without running around the site. And we're setting up only 2 buildings, and in each building will drop an 8-port WebSmart PoE switch with 2 gigabit SFP uplinks. It powers the cameras and gives us full gigabit SFP uplink back to our core. And WebSmart means we can simply control for things like VLANs, PoE budgets, and link setting. Handy if we ever need to diagnose our network remotely. So topology time, with 4 buildings, although we're displaying only 2 buildings, we are connecting fiber link from the core to each building. This is the most straightforward for cameras and makes our future upgrades painless. And for our link, we are using this pre-terminated single-mode pre-made fiber optic cable. This one has 4 string per cable with LC connector already on. Factory terminated, tested, and ready to plug in. And that saves splicing times and avoid field termination mistakes. So this indoor and outdoor cables support gigabit speeds over long distances. So let's build this. I'll start at the core switch. I already powered it up, and on a managed switch like this, you get centralized control and monitoring over those fiber uplink. First, I'm going to use a short patch cord. Connect from our switch Ethernet port to the network video recorder to display video footage. Then we'll need this. These tiny guys are SFP modules, hot swappable transceiver that convert our switch SFP slots into fiber port. And you have to match the SFP to your fiber type and distance. So now let's slide it into the SFP slots until it clicks. Now the switch has an optical interface. First, I'm going to use this 4-string fiber optic cable. Let's use string C and plug it into our SFP transceiver. Right, just 1 string. Because we're using BD-SFP, which sends and receives over a single fiber string using different wavelengths. And that's how we get full duplex on just 1 string here. But keep in mind, they must be used in matched pairs. And now we'll patch from the SFP to our 2-string LC connector pre-made fiber optic cable. Let's use string A. Now LC is compact and common in SFP gears, so they're easy to manage in tight space. So now we're all set and done for our 2 buildings. Let's coming over to our first building. Our building switch is the 8-port WebSmart PoE switch with 2 gigabit SFP uplink. 8 PoE ports fit 8 gears, and the SFP uplink brings us back to the core at gigabit speed. And with our BD transceiver, we are using string C. We cut our fiber usage in half and frees up extra string for future expansion. So we have 3 free strings. Then use copper cable, connect to the PoE port, sending both power and data using power over Ethernet to our bullet camera here. So our first building is done. Move on to the second building. We're basically doing the same thing. Slide in our SFP transceiver, then use our 2-string pre-made fiber optic cable. We used string A. Now some might wonder why we're using single mode, because we have to run up to 300 meters today. And single mode keeps us future-proof for even longer runs and higher speed. Now I'm going to use another copper cable to send both power and data to our bullet camera here. So basically, we are going to repeat this process for building 3 to 4, so we can get full and isolation between our buildings, and no worries about electrical noise. Now our cameras are lights up, and the video feed already pop up on our monitor. And all we need to do is repeat this process. I'm going to wave my hand so you can see their live video feed. And now our each building's uplink is independent. If one link goes down, the others keeps rolling. And now here's a neat optimization when your buildings are roughly in the same direction from the control room. Remember, our pre-made cable has 4 string because BD uses only 1 string per link, so we can reuse spare strings to hop to the next building as long as your routing allows it and you plan the string assignment carefully. Now let me show you. Here we have the 4-string fiber optic cable, and we are going to use this fiber coupler to join the cable. This is waterproof fiber coupler. I'm just taking it out for easy installation. Let's take out our protection cap. So I'm going to show you. We are going to be demonstrating 2 strings, so I'm going to use string C and D. Let's plug them into our coupler so we can extend our fiber optic cable. And for our building 1, we are using this fiber patch cord. String C, and then connect it to our WebSmart PoE switch. So we are still getting our first link from string C. And now for string D, let's come over to our main switch. Let's put it closer. We are using string D, so we have to plug it into our core also. So now we have string C and string T utilized. And for our 2-string fiber optic cable, we can just leave it here and connect it to our coupler to string D. Here we go. And since we have 4 buildings, so you have to add 1 more coupler so we can connect string A and B. Now as you can see, we only need 1 string fiber optic cable, 1 string with 4 strings inside, 1 fiber optic cable here from our core switch to the first and the second building. And our cameras are still working perfectly. And if you want to extend it to our building 3 and 4, all you need to do is add more coupler. So isn't it a neat way to use our 4-string fiber optic cable? And if you want to know more on how to add couplers along the way, you can watch our other videos. Now, since we're on managed gears on the core and the web smart in the building, we can tag a camera's VLAN end-to-end to isolate video traffic, set storm control so a misbehaving device doesn't flow the link. And that's the advantage of managed core. Central visibility over your fiber uplinks. So that's our 4 buildings, 32 cameras backbone. Clean, scalable, and rock solid over fiber. Each building has a WebSmart PoE switch, so all the cameras ride one fiber string back to our control room. Now, thank you very much for joining us. If this video helped, please don't forget to hit like and subscribe for more network builds. And feel free to tell us what do you want to see next. Maybe a ring topology with rapid failover. Now, I'll see you in our next video.